In this video, we're covering simplifying algebraic expressions. So the first thing we want to focus on is multiplying these terms first. So when multiplying algebraic terms, the times, not the x, the times is usually not shown. So for example, if we have down here, simplify 3 times a times b, all we really do is remove that times symbol. So what we end up with is 3ab. Okay. Same with this one, except this time now we have two numbers. Okay. So we focus on doing this first. So 4 times 5, sorry. So we get 20a. Again, down here, we have 2 and 3. 2 times 3 is 6. And now we have 6ab. Okay? So you multiply the numbers and then just remove the multiplication symbols. Alright, now we're going to look at dividing algebraic terms. So when we do these, make sure any common factors, so anything on the numerator and the denominator, or the top and the bottom, that's the same, can be cancelled out or simplified. So here we have 6ab over 18b. So 6ab over 18b. First thing we do is look for any common letters. So we both have b on the top and the bottom, so they cancel out. We then look at our numbers, 6 over 18. So 6 over 18. And that can simplify down to 1 over 3. So now we've ended up with 1a over 3, but we don't really tend to put the 1 there because it just means there's one of whatever it's timesing, the one letter. So it's a over 3. Okay, so simplify the numbers. So 6 over 18 turned to 1 over 3. Cancel out any pronumerals or letters that are the same. Alright, sometimes you'll see it expressed like this. Alright, so all we need to do here is we want to turn it into a fraction first. So 12a squared b over 3ab. So b's can cancel out. Now a squared over a. Okay, sometimes I like to think of it as like, oh, well, there's two a's on the top and there's one a on the bottom. Almost like, so if we write a squared over 3a here, you could rewrite this almost like a over 3a. You don't need to do it, but this is a good way to show you what happens. So that a will cancel one of those out, and there's still an a left. Okay, so now 12 over 3 turned into 4a. Okay, so sometimes writing it out in a long version can help, but really all you need to know, if it's a squared, there's two a's on the top and a on the bottom, so only one of those a's on the top will cancel out. Okay, next thing we're going to look at is collecting like terms. So like terms are whether they have the same pronumeral factors involved. It's important to note when you've got powers, so like 7x and 2x squared, we don't count them as like terms, right? They're different, all right? These like terms can be collected, what that means is added or subtracted. So an example would be if we have 5ab plus 7ab. They're like terms because they both have a and b in it. Equals 12ab. Now, 5ab plus 7ba still equals 12ab. Alright, the order that the letters appear in doesn't matter. They both still have an A and a B involved. Alright, so we're going to do some examples here. We have 3x plus 4 minus 2x. I think it's a good habit to build up is to underline or mark the like terms. So in this case, those are my like terms. So I'm going to go 3x, take away 2x is x. And then we have plus 4, that nothing happened to it. It didn't change, so we just write plus 4. We go down here and we do the same thing. There's an AB squared. There's an AB squared. We have a B and an A and a B, and then an A and a B over here. So I've marked my like terms. So 8AB squared, take away AB squared. Now, some people write 8 as the answer. That's not the case. You've got to think of it like we have 8 lots of AB squared at the front and then we're taking away one of those AB squareds, so we actually have 7AB squareds left. Then over here, we have negative 9AB plus 3, I'm going to write 3AB, so we end up with negative 6AB.